So welcome to a short video on how we can use molar volume to predict the volume of products and also how molar volume can be used in excess questions. So just to review, when it comes to gas volume calculations, 1 mole of any gas occupies the same volume at the same temperature and pressure. So 1 litre of oxygen has the same number of moles as 1 litre of methane. And in examples that only contain gases, you do not need to calculate the number of moles, you can just use volume. So for example, in this equation here where we've got methane, we know that 1 volume of methane, will react with 2 volumes of this to produce 1 volume of carbon dioxide and 2 volumes of H2O. So for example, if we said that 20 centimeters cubed reacted here, we would need 40 centimeters cubed here. We would produce 20 centimeters cubed of this and 40 centimeters cubed of this. So the molar ratio is also the ratio that we can apply to volumes. And it does make working with gases a lot easier because we don't always need to work out moles, but only in situations where we're only thinking about the gases. If we have to deal with solids and gases, we need to work out moles. So we've got an example here, methane burning a 50 centimeters cubed of oxygen. And I want to calculate the volume of the gaseous product at 120 degrees, and it's really important that we pay attention to the temperature. So we've got this equation. So methane reacting with oxygen to produce carbon dioxide and water. Now, important thing, at that temperature, we need to know that water will be steam. Okay, now from the question, the information we have, we don't know this. We know this is 50. If that is 50, and it is 2, 1, 2. If this is a gas, because carbon dioxide is going to be a gas at 120 degrees, we're going to form half the amount of that. So that's going to be 25. And we're going to have water as a gas, and it's the same number of moles, so it's going to be 50. So our overall volume of product is going to be 75 centimeters cubed, because remember, that's all reacted. Now, what would happen if the reaction was done at instead of at 120 degrees, what if it was done at 80 degrees? Well, if it was done at 80 degrees, carbon dioxide is still going to be a gas, so we'd have the 25, but our water is not a gas, because remember, water boils at 100 degrees. So at 80 degrees, it's only 25. So for questions like this, particularly if there's no state symbols, which is what we see in this equation, no state symbols, you need to look at what the temperature is and work out for water, will it be a gas or will it not be a gas? Now, when it comes to excess questions, it's the exact same principle, but you're given a volume of each reactant. And you're then asked to work out what the resulting mixture is. Now, resulting mixture means products plus leftover reactants. So whichever reactant is in excess, there will be some left over. So how I like to set out questions like this is I like to say what I have, what will get used up, what will be produced, and what is left over. So at the start of the reaction, C3H8, that's propane, we have 50. We've been told we have 500. Remember, you don't start with any product. Now, what gets used up? Well, firstly, products never get used up, they get produced. We have to look at, we've got 50 centimeters cubed of propane and 500 centimeters cubed of oxygen. The ratio of propane to oxygen is 1 to 5. So we can clearly see that this is in excess. So it's not all going to get used, but the 50 here is all going to get used. And if we use 50 here, using the molar ratio, we're going to use 250 here. Now, in terms of produced, well, no reactants ever get produced. If we use 50 here, it's a 1 to 3 ratio, so we're going to have 150 produced here, and that's a liquid, so we're not going to produce any gas. Now, how we work it out is we have this, we take away these numbers, and we add these numbers on. So 50, take away 50, add nothing, gives us 0. 500, take away 250, plus nothing, gives us 250. 0, take away nothing, add 150, gives us 150. And everything's 0 here, so that's just a 0. And then at the end, work out what's left over. It's all these numbers added together. So what we have is 400 centimeters cubed. That's what's left over. That is the resulting mixture. Now again, if it was at 200 degrees and we did the same thing, the water would now be a gas. So that would change. So what we have, use, produce, and left over. Well, remember we had 50, we had 500. We never have any products to start with. We used 50, 250. We don't use any products. We don't produce any reactants. But this time we would have our 150, but this time for water, we would now have 200 because it's a gas. Now remember, we take away these numbers and we add these numbers. So that's a 0, that's going to be 250, that's 150, and that's 200. So this time, when we add them all together, it's 600 centimeters cubed. So it's really important that we pay attention to temperature. But you can see if just setting it out in this format is really straightforward, and at the end we add them together. The only thing you need to pay attention to is, are they asking for how much product is produced, or are they asking for the resulting gas mixture? So hopefully that clears up gases and excess.